Hey guys, today we're going to be working with functions and performing operations, meaning that we're going to add, subtract, multiply, and divide functions. And then additionally, we're also going to find the domain of the new function. So in order to do this, we're going to review on how to find the domain of any type of function. Now, I put here as a reminder that radical and rational functions are the only kinds of functions that will have a limited domain. This means that its domain will not be negative infinity to infinity and will have some kind of what we call a restriction. Every polynomial type function has a domain of all real numbers. Now, just as a reminder, what is domain? Domain is the set of x values that make your function real, meaning that your function exists. If you were to look at the graph, you would have your function doing whatever it's doing through whatever x is. A polynomial type function means that it's just smooth curves. There are no breaks of any kind, and so that's why its domain is negative infinity to infinity. If we look at a, f of x is equal to x squared minus 7x, this is considered a polynomial type function. Now why? Because we just have these two terms. It's technically a binomial, but like I said, it's a polynomial type. You just have these two terms here that are being subtracted. So a polynomial is when you have multiple terms and they're either added, subtracted, or whatever the case may be. Since this is a polynomial type function, we can then determine that its domain would be from negative infinity to infinity, since it is all real numbers. For b, h of x is equal to the square root of 3x plus 12. This is a radical function, and you can recognize radical function simply because it has a square root. If it has a square root, remember that your radical, whatever is inside, can never be negative. So that means that 3x plus 12 has to be greater than or equal to 0. We can have 0 inside of the radical, we can have any positive number inside the radical, but you can never have a negative inside the radical because there are no two identical numbers that would multiply to give you a negative. So once you set up your inequality, then we use that to solve for x. So I'm going to subtract 12 to both sides, and I get 3x is greater than or equal to negative 12, and then we would divide by 3. So this means that x has to be greater than or equal to negative 4. This is the inequality that represents the domain. So I can put this on a number line if you'd like to visualize what the domain would be. The negative 4 would be included, and then we would shade everything to the right since x has to be greater than or equal to negative 4. So that means that the domain is going to be bracket negative 4 to infinity. Now this next function looks like a fraction. Anytime you see a function that looks like a fraction, this is a rational function. And because this is rational, right, the one rule for fractions, the one thing you cannot have inside the denominator is 0. So that means that the denominator, x squared minus 2x minus 3, cannot equal to 0. And then we would solve. So the reason we do this is because for rational functions basically have a domain of all real numbers except when that denominator is equal to 0, because you can't have something out of nothing, because fractions by definition are parts of a whole. So we do this to figure out what numbers would be excluded. It's easier to figure out what are the excluded values than it is to figure out what are the included values, like we do with the radical. So once you have this set up, if your denominator is a quadratic, you will have to factor. So x squared minus 2x minus 3 can be factored to be x minus 3 and x plus 1. And these factors cannot equal to 0. Remember, for factoring, you're looking for the two numbers that multiply to give you negative 3 and add to give you negative 2. Negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. So now once you have your factors set up, you would set each individual factor not equal to 0. and then we solve for each one individually. So for the first factor, I would have to add 3, so x cannot equal to positive 3. And for the second factor, I'd have to subtract 1, so x cannot equal to negative 1. So that means that on my number line, if I put these in order, it cannot equal to negative 1, cannot equal to 3, but everything else would be okay. So the domain would be from negative infinity to negative 1 parentheses because it's not included, negative 1 to 3, and 3 to infinity. Let's do a couple more practice questions. And these that we're about to look at are a little bit more complex and some special cases, which is why I want to review them. So for A, we have 5x over x squared minus 49. This is a rational function because it looks like a fraction. That means that the denominator, x squared minus 49, cannot equal to 0. Now, x squared minus 49 is a difference of squares. So it's called that because 1, it is a difference, right? We are subtracting. X squared is a perfect square, and 49 is a perfect square. As a reminder, a perfect square is anything that you can square root perfectly. So for example, the square root of x squared is x, and the square root of 49 is 7. So in order to factor a difference of squares, you would open up your 2 parentheses. We would put the square root of the first term first, the square root of the second term after, and then 1 is plus. So now that we have our 2 factors, we do the same thing that we did earlier. X plus 7 cannot equal to 0, and x minus 7 cannot equal to 0. This means that x cannot equal to, in this first factor, I'd have to subtract 7, so negative 7. And in the second factor, I'd have to add 7, so x can also not equal to 7. We put this on our number line. X cannot equal to negative 7 or 7, but everything else is fine. So the domain would be from negative infinity to negative 7. U, negative 7 to 7, U, 7 to infinity. Now in B, this is obviously another radical function because we have that square root. So we take the inside, that 4 minus x squared, and we make it greater than or equal to 0. And then we solve now for x. So I'm going to subtract the 4. And then we would have negative x squared has to be greater than or equal to negative 4. Next, we would divide a negative 1. Now, as a reminder, whenever you divide or multiply by a negative when you're working with an inequality, it switches the direction of the inequality. So right now we have x squared is less than or equal to 4. Now additionally, when we square root any number, we always get 2 answers. The square root of 4 is equal to plus or minus 2. When you're working with an inequality, this means that x is less than or equal to 2. This is the positive version. But just like when we divide by a negative, it switches your inequality. When you square root, the negative answer will switch the inequality. So x is less than or equal to 2, and x is greater than or equal to negative 2. Now when you put this on your number line, we have these 2 conditions for the domain. And the 2 numbers in those conditions are negative 2 and 2. And what I'm going to do is I'm going to graph on my number line both of these inequalities, one right on top of the other. So this first one is that x is less than or equal to 2. So that means that 2 is included, and we would shade everything to the left. For x is greater than or equal to negative 2 is included, and we would shade to the right. The domain of this function would be when both of these conditions are satisfied, meaning that you're looking for the section of this number line where they overlap, which you can see is here and here. Otherwise, in the other sections, the outside of that red bars that I put there, they do not overlap. So this means that the domain is bracket -2 to 2, and you close it with another bracket since both of these numbers are included in both of those number lines. Moving on to C, we have h of x. This is a rational function. And just like before with all rational functions, we take the denominator, x squared minus x plus 6, and you make it not equal to 0. Now you would try to factor. Now this one is a special case, and only because I already know what's going to happen. But if you were to try to figure out the two numbers that multiply to give you 6 and add to give you -1, let's make a list of all the numbers that would multiply to give us positive 6. That would be either 1 and 6, -1, -6, since two negatives multiply to give you a positive, 2 and 3, and -2 and -3. All of these multiply to give us positive 6. But if I were to add them, none of them would add up to give me -1. That means that this particular function is not factorable. If it is not factorable, that means that the denominator will never equal to 0. If the denominator never equals to 0, that is the only restriction on rational functions. So if it will never equal to 0, that means that there are no x values that will be excluded. So my domain, when this happens, would be -infinity to infinity. Moving on to D, f of x is equal to the square root of x plus 1 over x squared minus 5x plus 6, we notice that this is both a rational and a radical function. This means that we're going to have to make sure that both conditions are satisfied when finding the domain. So, for example, for this radical, I know that what is inside the radical has to be greater than or equal to 0. And if I solve, I get that x has to be greater than or equal to -1. Now, that's the radical portion, and that is going to be one of my conditions. So I'm just going to hold on to this information and come back to it later. And I'm going to continue because since this is also rational, that means that the denominator cannot equal to 0. And now I would factor. X squared minus 5x plus 6 can be factored to be x minus 2, x minus 3. And this cannot equal to 0. This means that if I were to solve each individual factor, x cannot equal to 2 or 3. Because for the first factor, if I make it not equal to 0, I'd have to add the 2, so positive 2. And for the second factor, I'd have to add the 3, so positive 3. So this is my second condition. And just like we did for B, where we did our number lines and we overlapped them, we're going to do the same thing for D. We're going to put all of this information on one number line stacked on top of each other and see where it overlaps. So I'm going to set my number line here, and I'm going to put all of these numbers in my conditions. I have -1, 2, and 3. For the first condition, x has to be greater than or equal to -1. So that -1 is included, and I would shade everything to the right. For the second condition, x cannot equal to 2 or 3, but everything else is all right. And now I'm ready to write the domain. If I look at where it overlaps, I see that it starts right here at x is equal to -1. And -1 is included in both number lines. So I'm going to put a bracket, -1. Now, as we continue, all of this is included, but we have these open circles at 2 and 3. Your domain for a function, if there are multiple conditions, will be where the numbers are included for both. So since 2 is not included for one of these number lines, I'm going to have to stop at 2. And I put a parentheses. And then I'm going to continue, so I'm going to start again from 2 to 3, because that's that middle section there, over here. And then I'm going to start again at 3, and then both functions continue to infinity after that. And that would be the domain for a rational and radical function combination. We've seen that before, but only when the radical was in the denominator, which is when you make your denominator greater than 0, since it cannot equal to 0. But now that the radical is in the numerator, we have to do both conditions separately. So now we're ready to start looking at function operations. As I stated at the very beginning, our operations are addition, subtraction, multiplication, and division, which the proper wording would be the sum, difference, product, and quotient. This, what you see here in the blue box, is the proper notation. You'll see there are 2 types, and just so that you can understand both, we have the parentheses f plus g parentheses and then of x. That does not mean to multiply x, it's just the notation for the functions. So f plus g of x, that's how you would read it. And that is the same thing as saying f of x plus g of x. And then the same goes for the rest of your functions. Once we figure out when we add and subtract, multiply and divide, whatever the operation is given to you, then we would have to find the domain of the new function. Okay, so I'm going to break that down now in one question, and then we'll look at several others. So we have here f of x is equal to the square root of x plus 3, and g of x is equal to the square root of x minus 2. So for A, I want you to add functions f and g. So that is your operation. Most of the time, the actual operation is the easier part of these types of questions. So we have f, which is the square root of x plus 3, and I am adding g, which is the square root of x minus 2. This is it. I would not be able to do anything more with this because what's inside the radicals are not the same. And you can only add radicals if the insides are the same. So that would be my new function, f plus g. Now for part B, we would need to figure out the domain. And I put some steps here for you to follow in order to figure out what that domain would be. So first, I put some steps here for you to follow. We are going to first establish the conditions of each individual function's domain. So here we go. We need to find the domain of f of x first. F of x, as we know, is a radical. So that means that x plus 3 has to be greater than or equal to 0, meaning that x has to be greater than or equal to negative 3. This is my first condition. Now I'm going to find the domain of g of x. And g of x is another radical. So we take the inside, x minus 2 has to be greater than or equal to 0, which if I add the 2, that means that x has to be greater than or equal to 2. So we have already established the conditions of each of those individual functions. Now we're going to put both conditions on one number line. So this is exactly what we were doing earlier, which is why I wanted us to do those functions first. So here's my number line. I'm going to put both of those numbers from my conditions, so negative 3 and 2. For this first one, x has to be greater than or equal to negative 3. And for the second one, x has to be greater than or equal to 2. The combined domain is where the shaded regions overlap. So we're going to look at our number line and we're going to determine where does it start overlapping, which is right here. So this means that the domain of f plus g of x is equal to 2 to infinity, where 2 is included because it's included in both of those number lines. So now let's practice. What I've done for all of these questions is I put a number line for f, g, and h. So you can already establish their domains right at the beginning, and that way when you're finding the domains of the new functions, you can just visualize those number lines one on top of each other and figure out where they would overlap. So for f is a polynomial type function. That means that It's all real numbers, so we would shade the entire number line. G is a radical, so x plus 2 has to be greater than or equal to 0, meaning that x has to be greater than or equal to negative 2. So I would put negative 2 on my number line, and everything is greater than that. Then h of x is another polynomial type function, so the domain would be also all real numbers. Now, let's get to the actual operation part. First, we're going to add f plus g. F is x squared plus 4x plus g, which is the square root of x plus 2. So this is f plus g. Now keep in mind, right, because every time I teach this, what happens is most of you think that I'm just looking for the domain, and I'm not. I want you to actually do the operation. So these are two-part problems. I want you to find out what the new function is, and additionally, you're going to state its domain. We were just focusing a lot on domain so that way we can review, because that is typically the harder part of these kinds of questions. So now that I have f plus g, I see that f plus g, right, is my polynomial plus my radical. So if I were to layer these two number lines together, they would only overlap starting at negative 2. And then it would open forever to infinity. For part B, we're going to do f times h. So that means that we're going to do x squared plus 4x, and I'm going to multiply 3x minus 5. Here you would have to FOIL. So we're going to distribute the x squared, which would give us 3x to the third minus 5x squared. Then we're going to distribute the 4x. So plus 12x squared minus 20x. Now I can combine those middle terms. So my final answer for f times h would be 3x to the third plus 7x squared minus 20x. And this would be f times h. Now the domain. I mean, if you look at your new function, it's clearly a polynomial. And when you look at f and h, both of those domains are negative infinity to infinity. So that means that the new domain is also going to be negative infinity to infinity. So now we're going to subtract. So when we subtract a function, we have f, which is x squared plus 4x. And I'm going to subtract all of h, meaning that when you're subtracting, you're going to open a parentheses before you write h, or your function that you're subtracting. So that way you would remember that you would have to distribute that negative afterwards. So now we're going to go ahead and distribute, and we would have x squared plus 4x minus 3x plus 5. So my final answer for f minus h would be x squared plus x plus 5. Now for the domain. Again, just like before, since we were doing f times h, and now these are your same functions, f minus h, this would give me a domain of negative infinity to infinity, since the domains of both f and h are also negative infinity to infinity. For D, we have h over f. When you're doing functions like this, h over f is 3x minus 5 over x squared plus 4x. You're not expected to actually divide anything at this point, so this would be your answer. Now, when we're trying to figure out the domain, if you look at the domains of f and h, yes, they are all real numbers. However, when you divide, this is no longer a polynomial. This is now a rational function. So in addition to figuring out the old domains and rather like putting those conditions together, you also have to take into account that the denominator now cannot equal to 0 since this is rational. X squared plus 4x is another quadratic, so you can factor. Now this does not have that third term, so you're not looking for what two numbers multiply to give you the last, but instead you're looking at the two terms and seeing what they have in common. they both have an x in common. So I can factor out an x, and then inside my parentheses, I'd have x plus 4. Now that I have my factors, I would set each factor individually to not equal 0. For this first one, x cannot equal to 0. That is one of my answers. And for the second one, x cannot equal to negative 4. So these are my two conditions, which again I can put on my number line. X cannot equal to negative 4 or 0, but everything in between is fine. So that means that the domain of h over f is going to be from negative infinity to negative 4. U negative 4 to 0, U 0 to infinity. Let's look at a few more examples. Alright, so first we're going to determine each of the individual conditions for the domains of f, g, and h. F is a polynomial type function, so that means that its domain is all real numbers, so the entire number line. Now g of x is a square root, so remember we'd have to do 9 minus x squared, the inside of the radical, and make it greater than or equal to 0. And this is a similar example to the one that we did earlier on in the lesson. So I would subtract the 9, and I have negative x squared has to be greater than or equal to negative 9. Divide negative 1, and this means that x squared, remember I divided by a negative, so it's going to flip my inequality, has to be less than or equal to 9. The square root of 9 is not 9. Oh wait, yes, just kidding. Sorry. So now we square root. Now when we square root, remember there's always the two answers. Your positive version keeps the inequality, so x is less than or equal to 3. And the negative version flips the inequality, so x has to be greater than or equal to negative 3. So now I'm going to put these two conditions on my number line. So I have negative 3 and 3. X has to be less than or equal to 3. So 3 is included and everything to the left. X has to be greater than or equal to negative 3. So negative 3 is included and everything to the right. That means that the domain for the square root of 9 minus x squared is everything in the middle, because this is where it overlaps. So I'm just going to put it in red so that we can just see in total what the domain would be. Now for h is another polynomial type function. So the domain for this would also be all real numbers. Now, let's do our operations. We have g plus h. So that means that g is the square root of 9 minus x squared, and then I'm going to add h. So plus x squared minus 3x minus 4. If I could combine, I would, but there's nothing left to combine. So we leave it just like that. Now the domain. The domain of g and h, we see that the domain for g is the only one that is restricted from negative 3 to 3. So if I layer it on top of h is all real numbers. The only time that both of them would exist would be when they would overlap, which would be from negative 3 to 3. Now we're going to do f times h. So that means we're going to take f, which is x minus 4, and I'm going to multiply all of h, which is x squared minus 3x minus 4. And here I would have to distribute the x, and then later distribute the negative 4. When I distribute the x, that would give me x to the third minus 3x squared minus 4x. And now when I distribute the negative 4, that would give me negative 4x squared plus 12x plus 16. Now that I've distributed everything, I can combine like terms. So x to the third minus 7x squared plus 8x plus 16. And this is f times h. Now, because the domain of f and the domain of h is negative infinity to infinity, that means that the domain of my new function is also negative infinity to infinity. Now we're going to do h minus f. So we have x squared minus 3x minus 4 minus all of f. So remember, open that parentheses, x minus 4. I'm going to distribute the negative. So x squared minus 3x minus 4 minus x plus 4. The 4's would cancel. So my final answer would be x squared minus 4x. So this is h minus f. Again, the domain of f and h is negative infinity to infinity, so the domain of my new function is also negative infinity to infinity. Now for this last one, we have g over h. G is the square root of 9 minus x squared over h, which is x squared minus 3x minus 4. I can't do anything else with this. This is g over h. But now remember, we need to find the combined domain. Now the domain of g is from negative 3 to 3. So I already know that that is my limitation here. And I'm just going to keep that in mind for when I have to find my new domain. But this is now a rational function. So remember that for rationals, the denominator cannot equal to 0. So x squared minus 3x minus 4, I would have to factor, which is x minus 4 and x plus 1, which cannot equal to 0. This means that if I were to solve each factor individually, x cannot equal to 4, because I would have to add the 4, and x cannot equal to negative 1, since I'd have to subtract the negative 1. So now I have this additional condition. So I'm going to put everything on my number line. Because of g of x, remember those numbers here, negative 3 and 3. So I'm going to start with the negative 3. I have the negative 1 from this condition, the positive 3 from the g of x condition, and then the positive 4. So as we see in the original number line, g of x is only defined from negative 3 to 3. But then for the new function, the division, right, the rational function, x cannot equal to 4 nor negative 1. And so now I would write down everywhere that they would overlap. And as we can see, it only overlaps where g exists, which is from negative 3 to 3. But we have that hole here in the middle. So for my domain, we would start from bracket negative 3. I would have to stop at negative 1, which is not included. I'm going to start at negative 1 again, and then would stop at 3 bracket, since g of x does not exist past that. So that would be the domain for our new function. And those are your function operations.